Hello, everyone. I am Ping-Yeh Li, Assistant Professor in the Department of Arts and Design of National Taipei University of Education. I am very excited to serve as a lecturer for the New Media Art Online elective course. With transformations of technology and the environment, technology and art are being combined with more diverse methods. New characteristics of art have also been born. For example, generative, interactivity, and fluidity. Since the 1990s, computers and the internet have advanced by leaps and bounds. This has created new styles of art and given new media art a new look. Recent changes include the explosion of information in modern society, personalized media, and diversified audio-visual media. These have also spawned some new explorations. For example, the new media art we now often see in art galleries. There are, for instance, immersive audiovisual theater performances, mechanical installations that interact with viewers, and spontaneously produced audio and visual environments. There are even augmented reality and virtual reality artworks. These have all given viewers more freedom and more sense of gameplay. This has also given artists a new range on which to perform. Within these new trends, coding plays a role as a bridge of communication in the collaboration of artists and computers. In recent years, coding has also become a very important tool for creators of new media. Through programming, artists can use the strong functionalities of computers and the internet to complete more impossible and interesting tasks. In the next 3 modules, I will teach you methods of programming, that is, methods of coding, to create graphics and sounds. With a tool often used by new media artists called processing, I will help you understand the concept of artistic programming and the expression, appreciation, and implementation that can be derived from it. I hope that all of you, through practice, can better understand the logic and methods created by new media art. Processing is a type of open-source programming language. In 2001, it was developed by Casey Reyes and Benjamin Fry of MIT Media Lab. Its purpose was to provide artists and designers with an easy-to-use programming tool. Since processing is open source, it is completely free, and it is continuously updated and enhanced. In recent years, it has been widely used by new media artists in Taiwan, including Shen Shengpo, A Luan Wang, and Lian Cheng Wang. I have also used processing to develop and publish multiple works. In a little while, I'll explain more. In today's class, I will teach you how to download processing and give you a basic explanation of processing interfaces, its basic syntaxes, the relationship of on-screen coordinates, the sequence of programs, and how to draw geometric figures. I will also teach you how to save your own individual coding projects. Let's start today's demonstration. Everyone, I will now teach you how to download processing. First, if you search for processing on Google, then the first search result you will see is processing.org. You can just click the link for the official website. At the top left of the official website, you can see that Download is in the upper left, right? Download. After you click in, then it will here show that there are many different packages. If your operating system is Windows 64-bit, then select the 64-bit option. If you have a 32-bit operating system, then select this one below. If you are using a Mac notebook today, then you can select Mac OS X on the right. Let's try Windows 64-bit. You will see that at the bottom, it will start to download processing for Windows. If you want to know the download progress, you can open Downloads in the top right. Then you can see the status of processing as it downloads. You can see that this download may take a while, After downloading is complete, we will continue. Now, processing has been completely downloaded. You can see it in this computer's downloads folder. We can see on the screen that we can decompress it. Now decompressing. It is now decompressing. This will also take a little time. Decompression is almost finished. It's finished. It will decompress into processing 3.5.4. 3.5.4 is the current version of processing, so if you watch this video after a period of time, there might be an updated version. When we click into this folder, we can see that it contains processing 3.5.4. This folder, the one that doesn't have Windows 64 at the end of its name. Please make a copy of this folder. Copy. Where do we paste it? Open the C drive on your computer. In the C drive, you will see program files. There are files for your programs. This is where Windows keeps programs. Just directly paste it here. It might ask you whether you are the administrator. Just click Continue. If you are installing it on Mac OS, it's also simple and similar to this. You also do it with cut and paste. When you download the Mac installation file, it comes with instructions. On the screen, you can see that processing 3.5.4 is now in Program Files. This is the processing program that we downloaded today. Pretty simple, right? Now, please click into the folder where you will see Processing's executable file. Right-click it. You can send it to the desktop to create a shortcut. Now, whenever you turn on the computer, you will see processing on your desktop. You won't have to go into Start or wherever to find it. So we have now created a shortcut on the desktop. You can see that there is now a processing shortcut on your desktop. We can open it by double-clicking. Now, on Processing's official website, there are some learning materials. I'll briefly introduce these to you. So let's go back to the official website. You can see here, reference on the right. Of course, something to mention here is that because we are writing code, we must use English to type. So, I think and hope that you can all get used to using English this way to search for information on coding. At the top of the processing website, they provide a lot of examples and supplements for programming syntaxes. For example, with the one we will talk about in today's course, 2D primitives, which is for basic geometric figures. When you click, for example, the line link, you will see on the screen some ways to write line. For example, this line, 30, 20, 85, 75. What are these? They are actually all points. 30, 20 is the coordinates of the first point, and 80 and 75 are the coordinates of the second point. We know that to draw a line, we must have 2 points, right? So in addition to this line, 30, 20, 85, 75, there is also a picture. This picture is the content that is drawn with the 2 points of this line syntax. All syntaxes are on Processing's official website for your reference. In addition, there is another link here. They are examples of works in processing. So the website is processing.org. Just add exhibition at the end. But what's interesting is that recently this link has been removed. So you might have to key it in yourself to find it. Let's look at just 2 processing examples. For example, let's go to page 12. Page 12. Scroll to the bottom. Here you'll see one by Mary Huang. She is a clothing designer. There is a work here called Continuum. What kind of work is this? You can see that what she has done is clothing design. But the most interesting part is that this clothing design wasn't done by hand, but instead used programming to create this geometric appearance of the clothing. So you can see that it has some aesthetics of computerized geometry. This is one application of processing. Additionally, there are other examples here. For example, on page 13, we can see city symphonies. I remember that this is a British designer. He imagined the roads of London as music staffs and then simulated the flow of traffic. Then, according to the distance between the cars or the distance between pedestrians and cars, it creates some interesting sounds. There is a link to a video here. You can click it and have a look. You can see that he has simulated this kind of urban traffic flow to generate a type of interesting electronic music. This is a later stage application of processing. So you can see that on its official website, there is a lot of very good content and content that can give you inspiration. You can go on it and have a look. After you finish downloading processing, we can click on processing and open it. Let's explain a bit about the processing window. I still recommend that everyone uses the English language interface. Actually, its interface is quite simple. At the top of this window, there are lists of tools. For instance, there are things that we always need while coding, like save or save as. At the top, there's also, put your cursor here, this is run or execute. Actually, as you haven't typed anything, you can try running. Just click accept here. You can see that it opens a very small window on the top of this window. This is the current program's display, the display window. If you want to stop execution, then you just click Stop here. That's the toolbar. Our program editor is in the middle of the window. For example, I'll key in some content for everyone to see. This is the size. It determines the size of the window, size 400. You will see that this program is a combination of English syntaxes and numbers. So what does size 400 mean? It will adjust the size of the window to 400 by 400 pixels. Let's run it now. Can you see it? You can see that in our picture now the window has changed to 400 by 400 pixels. This kind of syntax is called intuitive syntax. That means as long as you know basic English words, you can guess what the syntax is used for. Interesting, right? Don't forget that at the end of each code, at the end of each line, you need to add a semicolon. Syntaxes for a lot of coding end with a semicolon. Processing also works this way. At the bottom, there is something called console. This is a message bar. I will talk about this later. It lets processing tell us information about program execution. Now, we will move on to the next part, Settings and Preferences. So, please click File, then Preferences. These are your settings. You can actually change anything in here. What are the main changes you can make? For example, language is here. English. You might notice that it actually has a Chinese interface, but really, I think that these kinds of interfaces aren't too complicated, so I recommend that you use English. I'm sure that you will get used to this kind of interface very quickly, because if you choose Chinese, you will have to translate these actions. Then, there is Editor for font size. What is this? This is the size of the program editor font in our current window. It is currently set to 18. If you think that it is too big or too small, you can change its size. For example, if I change it to 16 now, type in 16 and then press OK. You will see that the size of its font is 2 degrees smaller now. You can adjust it back. Generally, it is recommended that after you adjust the font, you restart processing. Restart it. That is, you have to close it and then reopen it. That way, your settings will be more normal. Now, we will explain processing's canvas or sketches. Sketches actually are a concept often used in artistic design. It's not called program. Programs are for coding. So, in processing, although you use code to write, it was set up to make content created by artists and designers. So it is a sketch, kind of like a hand-drawn draft. We will now give a demonstration of how to save. That is, in a moment, if you have something you want to save while you're using the program, you can do it anytime. So, click File, then click Save. Then, in the same way, you can select your destination for saving. Let's suppose that we want to save it on the desktop. For the file name, there are some things you have to remember. That is, the name of this program. You can't use Chinese to name it. You have to use lowercase English and numbers, half-width letters, and numbers to name it. I recommend that, for example, you can describe its contents. For example, we can call this practice. Today is the first time everyone is practicing. At the end, you can add an underscore. If you shift to type an underscore and then hit the button to the right of the numbers, then the dash will turn into an underscore. Next, you can add today's date, for example, or just the month could be fine. For example, 202007. So this project will be saved with the name practice_202007. So then you'll be able to remember more easily when this program was created. So that is the way that you save. Everyone can give it a try. Now I will explain processing's coordinate relationships. Like I talked about earlier, we must have 2 points to draw a line. So we have to understand processing's coordinate relationships. In processing's window, the origin is in the upper left corner. So you can see that in the PowerPoint, the upper left corner is the 0, 0 position. Then, the x value grows from left to right. So the leftmost point is 0, and it goes up as you go right. Y increases from top to bottom. So you can imagine that we are at the point marked A in this picture. Its x-coordinate is the 4th from left to right, right? And the y value is the 5th from top to bottom. So we use 4, 5 to notate point A. But this is an enlarged state. Everyone knows that the sketch we just opened is 400 by 400. From 0, the x value increases from 0 to 400, and the y value also increases from 0 to 400. So now we know that this is how processing's coordinate relationships work. From the upper left to the lower right, We already demonstrated how to adjust the size of the sketchbook. Everyone can see what happens if you adjust the size to, say, 600, 600. It will directly change the canvas's size to 600 by 600 pixels. While we are writing this program, we need to remember that everything is written in lowercase. You have to write everything in lowercase. So if you capitalized the S in size, you will see that a red message immediately appears below. It will tell you that size, capitalized this way, is a syntax that doesn't exist, so you have to remember this. Also, make sure to remember to add a semicolon at the end of each line. Let's continue. Now, we have a different sized canvas. Let's change the base color of the canvas. What is the English term for this? Can any of you guess? The English term is background. So, we will now key in background. Easy to guess, right? Then, we need to type out these two parentheses and lastly, add a semicolon. This is a good habit. We first type out the syntax structure. Now, if you are on the official website, you can also see that background takes 3 numbers. These 3 numbers are RGB, a numerical way to represent color. So let's suppose that we want a purplish color. How do we input it? Now here, for example R, the value for red, let's type 200. G is green. Because we want purple, we can set the value of green a little lower. And then B is blue, so we can make this a little higher. So I have typed 230, 230. Now, let's close the program and run it again. Now you'll see in the window that it has a purple background. The only thing you have to pay attention to is that each RGB value has to be between 0 and 255. This is a rule of this syntax. You can all give it a try and see if you can create your own color. Processing also has another very useful tool. In the toolbar, Tools is here. Tools, right? In Tools, you can find Color Selector. It's a tool that allows you to select a color. This is extremely useful, as you can see. Suppose one of you wants to reproduce a color of the ocean you saw in a dream yesterday. How do you type out the color of that ocean? It would be a little hard, right? With the color selector, you can find in the selector, for example, a pretty blue-green color. After I select a blue-green color, you can see that there are 3 RGB values at the bottom. They are 2, 227, 225. Now we can use these numbers 2, 227, 225. Key them into our program. Now, let's run the background color again. Can you see that the background color has changed to a very pretty bluish ocean color? You can give this a try. You can try making a color that you really like. Have you all been able to set your own pretty background color? Now I will teach you how to draw a circle. The rule for circles is the syntax ellipse. Ellipses are different from circles. With ellipse, you can draw circles. You can also draw ovals. How do we write the parameters for this syntax? You have to input 4 parameters. The first is the x value of the center of the circle. Next is the y value of the center. Then is width and then height. Now, let's give it a try. Currently, our sketchbook has a size of 600 by 600. Let's try drawing the circle at the very center. The very center has x and y values of 300 and 300, right? Because now it's 600 by 600, so the center is at 300, 300. Then, the next two numbers are the ellipse's width and height. Suppose we want to draw a 150 pixel circle. 150 pixels. You can see that when your code is written correctly, the red message underneath disappears. Let's run it now. Can you see it? In our screen now, there is a very pretty circle. A white circle is in the middle of the window. You can now give it a try. You can also adjust the position of the circle. For example, we can change it to the 350 position, then adjust its size. For example, to 200 150, and try running it. You'll see that your ellipse has a different height and width, and a different position. There are many different possibilities. You can give it a try. Now, we can also, for example, draw a rectangle in our window. Let's try drawing a rectangle. The way of inputting a rectangle is the same. There's also a center point that has an x and a y coordinate. Then there is width and height. That's the way we input it. Rect is rectangle shortened. You'll notice that my habit is to first write the parentheses and the semicolon, so that I don't forget them. Let's give it a try. In the same way, let's draw the rectangle in the center, 300, 300, 300, 300, 80, 80. We'll close it now and run it. You can see that a rectangle was added above the circle. Let's make the rectangle bigger and have a look. 180, 180. It's a lot of fun. You can adjust the values and it will generate a new shape. You can try practicing. We already demonstrated how to draw with line. You can try it yourselves. You might have noticed that all of the geometric shapes I've done are white. The color of them is white. You might ask if you can change their color or change the thickness of their outlines. This is, of course, possible. Let's look at the slide about changing filled colors. Now that we are going to change filled colors, there is one thing to remember. The code has an order. Just now, we put the rectangle underneath ellipse, so it draws the rectangle on the circle. It overlaps on top of the circle. What does this mean? Processing reads code from top to bottom. It reads from top to bottom, line by line. So whatever you enter later, like this rectangle, will be drawn later. You can imagine that this is a piece of construction paper. The things that we add later will cover up the things we draw earlier. You can see that it has first drawn the circle and then drawn the rectangle. If we want to change the color of the geometric figures, we must first write the code of the color we want to change it to before the figure is drawn. We are now one line above the ellipse. Press Enter to add a line and then key in the color change. It is written as fill. Fill means to fill up, right? It's the same as when we learned about background. You use 3 numbers, RGB, to fill the shape you draw with the color you want. Now let's change it to a more bluish color. For example, we'll use 50, 100, and then at the end type 255. That is, the blue value is the highest. It will be a more bluish color. Give it a try. Can you see? In the window, you can see that the rectangle and the circle have both become blue. If you want to make them 2 different colors, that's also easy. You have to add another line above rect, the rectangle, and then input fill. Now, we will use copy and paste, which is very convenient. After you copy and paste it in, you can see that all we have to do is change the values. Now, we can, for example, raise the R value a little. Let's try it. Let's try making a reddish rectangle. You can see the change now in our code. Let's run it. You can see that they now have different colors. Let's lower the green value a little. That will make it closer to red. You can see that we have size settings, background settings, and then we change the color of the circle. Draw the circle. Change fill color and then draw the rectangle. This creates the content that we now have in our window. Now, how do we change the borders of our shapes? We can also add this in. You can see that while coding, you can always add additional content. And don't forget, if you like the current version, you can save it. We have already named it. So now all you have to do is click Save. Then it will save it on the desktop. Now, we will use stroke, which is a method that changes the brush color. For example, now the borders are the default black color. Let's change them to white. White. How do you express white with RGB? White is all of the colors at their strongest. So you should type stroke 255, 255, 255. That is, the three largest values. Let's give it a try. You can see that the borders become white, right? Now, this border seems to be a little too thin. We can also change the thickness of the border. For example, we can use the syntax stroke weight. You need to remember that because it is the combination of the two words stroke and weight. The first letter of the second word W needs to be capitalized. Many syntaxes have this rule. So let's use stroke weight to make it a little thicker. Let's change it to 20 pixels. Can you see it? Stroke weight and 20 in parentheses. This line will make everything that's drawn below have thicker borders. Can you tell? Through just a few simple lines, we created some geometric shapes. You can give it a try yourself. On the official website, there are other syntaxes. You can have a look at them and practice. For example, with irregular rectangles, you just need 4 points. Or for triangles, you need 3 points. On the official website, in the 2D primitive section, you can find all of these. For example, triangle is here. Now we can directly copy this triangle. Copy it. Then we can paste it in. Let's see how it looks. Really convenient, right? You can see in the window that there is now a triangle. You can try changing these values. For example, I'll make one with these values bigger. What will change? You can see that the shape has changed. You can try using processing's 2D primitive syntaxes to draw some shapes that you like in the window. You can try practicing with these. Don't forget that the program has an order. Things written towards the end will be drawn towards the end. They will cover up things drawn earlier. And don't forget that if you forget how to write some syntaxes, there are some things you can do. The first thing is going onto the official website and looking for reference. Another good method is right-clicking the syntax in your program. Find in reference will appear as an option. It will look it up in the online reference. As long as your computer is connected to the internet, you can use it. Interesting, right? It links directly to the stroke weight syntax on the official website. You can directly copy this code into your window. You can see that it is stroke weight 10, right? All you have to do is paste it in and you can use it. So when you are coding and processing, you don't have to memorize all the syntaxes. You can find them on the official website. Now, we will have free practice time. Please try using these basic syntaxes of processing to create your own combination of shapes in your window. Everyone, I will now share a spatial form piece that I developed with processing. This work was exhibited at the National Taiwan Museum of Fine Arts in 2018 in the panoramic projection space. We can watch a video of this work. I put it on YouTube. If you search Flower of Time, Universal Correspondence, you will be able to find it. I used processing to control 10 projectors for a seamless 360-degree projection to make these simultaneously generated images appear on the screens. Now we will use another program to explain. You can see on the screen my Flower of Time. This is content from when it was being developed. You can see that there is data on time. Now, this is the time the video is being shot. It is 1:26:51 in the afternoon. You might notice that the flowers in the screen have shapes and colors that change with the time data. At the bottom of the window, I used processing to write some calculations for these colors. That is, after I wrote the system automatically updates the colors of Flower of Time as well as its forms. That is to say, at any moment, when a viewer walks in, they will always see a unique combination of flowers. Actually, the concept is very simple. The clocks that we had in the past, you can try to imagine what these clocks were like. They had hands that continuously rotated. Can we digitally recreate this aspect of clocks? Can we make every minute of every second have a unique appearance? I have used processing to specifically manifest this kind of idea. So programming for artists is really a very useful tool.